West Legal Ed Center would like to welcome you to today's program, The Reality of Generative AI in Litigation: What's Real, What's Next, and How to Prepare. Please use Participation tab to send questions to your speakers, and your materials can be found under the Supplements tab. Thank you for joining us. I'll now turn things over to our speakers to start the program.
Yeah, good morning, good afternoon, everyone. Welcome. Thank you for joining us today. My name is Matt Collins. I'm a director of project management at Simplify. I have over 20 years of e-discovery experience in managed review, project management, and advanced analytics as a program lead, as a team lead, as a staff attorney in the e-discovery department of a large law firm, and as senior director in the e-discovery vendor sector. Great to have you with us today. We're really looking forward to this discussion, this presentation. And my co-presenter today is Chan-Hee Ko. Chan?
Thank you, Matt. Hi, everybody. My name is Chan. I'm a co-founder and CEO of Fileread. I have over 8 years of experience in both engineering and product development, and I really focus on working closely with attorneys to help them address the key pain points in the litigation process. And Fileread is an AI tool that enables attorneys to find the facts that matter and to uncover the hidden stories in their data. It's an application that plugs directly into Relativity, so litigators can really enjoy the power of GenAI in a familiar environment of where they operate. So cool. So before we begin, I wanted to break the ice with something fun. So GPT-o1 is a pretty cool model, and GPT-o1 is the latest model that was released on September 12th by OpenAI, and it's a state-of-the-art model designed to spend more time thinking before responding. And so really to test the pinnacle of machine intelligence, I naturally had it solve my New York Times connections for me. And in just under a minute, it was able to find a distinct group of four words that were uniquely linked to each other. So I tested it with other models like GPT-4 Omni and Claude Opus, and those unfortunately failed the task. So the progress that we've seen in this space is so unprecedented, and it's going to be extremely exciting to see how these evolving foundational models can be applied to specific litigation tasks. Now I'm going to turn it back over to Matt, who will help us level set on the nomenclature and provide an intro into some of the use cases of these technologies.
Yeah, that's great. Thank you, Chan. Yeah, AI has very much been in the news, of course, all around us. For anyone at FEST, it was prominently featured in meetings and discussions on AIR for review, AIR for privilege, for example. It was the focus of FEST, really. And just this past month, multiple Nobel Prize awards were tied to their work in AI, in physics and chemistry. I'd like to first, I'd like to first talk about AI in related terms, a bit of a recap or overview. The term artificial intelligence is often used interchangeably with a number of related, but often more complex or more discrete terms, such as machine learning, deep learning, generative AI, ChatGPT, NLP, natural language processing. I'd like to begin by going over those terms, their definitions, so we can level set, align on what we mean by those terms. I've found that at times, what we're speaking to can slide or drift within or across this collection of terms, this toolkit of technical resources, as we conflate or confuse terms, creating some disconnect or dissonance in those discussions. An example of the myriad related terms and how they mix in conversation are seen here on this slide. Terms that might come to mind in thinking about or discussing AI, generative AI, or ChatGPT. This group is, of course, not exhaustive or exclusive, but I think it is representative of the number of terms that can flood such a conversation. There we go. Sorry. So AI, what is AI? AI is the broad concept of machines simulating human intelligence. It's been around for a long time and has very broad applications. It's a superset, if you will, that includes all the subdomains or parts of AI, which I just briefly alluded to or just referenced, or that we just viewed in the previous slide's word cloud. Natural language processing, or NLP, is a field within AI that focuses on the interaction between computers and humans through natural language, as the name would suggest. Further, natural language processing is AI that allows machines to understand and interpret human language rather than just read it. Machines can use NLP to understand written or spoken text, and NLP enables computers to generate content which can be manifest or expressed in that same way. Examples of NLP or applications are seen here. It include search autocorrect, speech recognition, language translation. Text classification isn't listed, but that's another application. Sentiment analysis. You can probably easily imagine or see how this is being used in your everyday life in many different contexts, and in some instances has been for some time. The Alexa in your home, for example, or an equivalent, employs natural language processing to understand and respond to voice commands. When you ask Alexa a question, Alexa uses natural language processing to understand what you're saying. Then Alexa uses it once more when formulating a response that you can understand. And in between, or in addition to the application of NLP, Alexa uses machine learning to improve its responses over time by learning from user interactions. And that's something I think that we'll see and as throughout this discussion demonstrates, showing how different parts of AI are often used in combination. Another simple example is autocomplete. That also uses NLP and machine learning algorithms to predict, for example, what words or sentences will come next. Apologies, I skipped past. There we are. Machine learning is the science of developing algorithms and statistical models that computers use to perform complex tasks without explicit instructions. It's a data analysis technique based on the notion that systems can learn from data, recognize patterns, and make decisions without human intervention. An example, the Netflix recommendation system is powered by machine learning. Netflix makes personalized recommendations for users based on what other similar users enjoyed or didn't enjoy by analyzing all of their viewing data. Another example, facial recognition. We previously received name suggestions for mobile photos or Facebook tagging, but now someone often is immediately tagged and verified by comparing and analyzing patterns through facial contours. Machine learning is a branch of computer science that deals with designing computer programs to extract information from examples. In e-discovery, properties that distinguish between non-responsive and responsive, for example, or distinguish between responsive and non-responsive documents may be extracted from example documents in each category. The goal there, as it is in other machine learning contexts, is to predict the correct category for future untagged examples based on the knowledge extracted from previously classified, labeled, or categorized examples. That's machine learning. Natural language, I may have gone one too far. Oh, there we are, sorry. Sorry, we're on the wrong slide. There we go. Deep learning, my apologies. Deep learning is the stage of AI that evolved out of machine learning. It's much more sophisticated, drawing many more connections between data. Deep learning is what enables the multi-layered analysis that we see in large language models, or LLMs, which we'll see on the next slide. Deep learning is a type of machine learning, a subset of machine learning that uses multi-layered neural networks called deep neural networks to simulate the complex decision-making power of the human brain. Deep learning involves training neural networks on large data sets. So contrasting these last two concepts, machine learning and deep learning, machine learning involves algorithms that learn from structured data to predict outputs and discover patterns in that data. Deep learning involves algorithms based on highly complex neural networks that mimic the way the human brain works to detect patterns in large unstructured data sets. Further contrasting the two, machine learning and deep learning, machine learning requires less data, requires you to train the model, and is faster than deep learning. Deep learning requires a lot of data, no training. You feed the data into the model. It takes longer, but is more highly accurate. Large language models, or LLMs, is a type of AI algorithm based on deep learning and huge amounts of data that can understand, generate, and predict new content. Just what types of huge amounts of data are we talking about? An LLM is in the petabyte range, which is 1 million gigabytes. Some LLM challenges are cost, bias of the data trained on, and hallucinations. We'll get into this a little bit more, but very simply, responses that are not based on the training or underlying data. LLMs use cases and applications are shown here on the slide. One general example that many of you may use already is the Zoom meeting summary with AI Companion. I believe it's named Spark. It's listening to your meeting and providing a written summary, preset categories. That Zoom or AI Companion is typical in that it uses many of the AI techniques that I've mentioned thus far, including large language models, whether they're proprietary to Zoom or models taken from other leaders in the field like OpenAI, as well as GenAI. GenAI is a subset of AI focused on creating new and original content. Unlike traditional AI systems, which operate based on pre-existing data and rules, generative AI creates or generates new data and ideas, from novel text to images to digital art. Generative AI tools are large machine learning models that take instructions or prompts and create or generate credible sounding novel content by applying a statistical model to the data, to the material that they're being trained on. GenAI tools or models can be subject matter specific or directed towards specific applications. Some of the better known examples are for text, ChatGPT, for code, GitHub Code, or GitHub Copilot, or OpenAI codes. For images, DALL-E 2, OpenAI's recent version of their GenAI tool for image and art generation. There are a lot, there are many. Jasper, Gemini, Claude, Microsoft Copilot, of course. And the investments, there are quite a number, and the investments that are being made and planned in the very near term alone are really fantastic. And here's a slide that gathers all these concepts and terms together again in a relational way, in a bit more coherent way, perhaps than the word cloud near the beginning. We see AI as the superset of numerous branches or subparts within that field. So again, AI is the broad concept of machines simulating human intelligence, while these other myriad areas reflect specific techniques or applications of AI within it. Now let's talk about applications and use cases of AI in e-discovery. An early and ongoing application of AI in e-discovery in the law is with regard to contracts. But the nature, application, and value of leveraging AI in drafting, negotiating, reviewing, managing, and analyzing contracts has changed significantly as of late, I would submit. Here again are some of the key applications of AI in contracts laid out. Now, contracts, of course, are critical documents, but they're often long, dense, littered with key data points, sometimes hundreds of them. One problem is that for a long time, even today, a contract is signed, it goes into a repository, and a company may have thousands of PDFs with no real metadata, and all these key data points in a contract locked up in the PDFs. So contract title, type of contract, renewal, effective date, parties, assignment are just some of the basic info in a contract, but when you drill into the clauses, each clause might have 10 key data points that answer important questions for the business around risk and obligation. AI allows you to focus contract review and analysis quickly and even at a high level. How? Well, one example of contract analytics tool that I can share with you is simplifies innovation or CI contracts. The idea is using a large language model. Further, by integrating that model into Relativity, as done here, you can greatly streamline and automate contract review processes. The LLM in this application replicates traditional contract analytics, extracting critical clauses and answering fundamental questions such as parties involved, governing clauses, start and end dates, force majeure, and so on. It facilitates myriad contract management workflows through AI-driven auto redlining, GPT answer or question and answer, clause library and suggestion, risk scorecard, etc. A number of those functions in the UI are shown on this slide and then on this next slide here. Another recent use case that I experienced concerning a different contract analytics application reflected a client pulling pertinent contract info for the core contract terms, identifying and pre-populating field info for validation or updating, but also for downstream further analysis. And it really drove, I think, in a very clear and apparent way, speed and consistent work product in that project. Another early and ongoing application of AI and e-discovery in the law is with regard to legal research. Using Westlaw, Lexis, Casetext for legal research, it's much more than keyword searching or filtering on coded criteria. In addition to the use cases that you see on this slide, you're using machine learning and LLMs to synthesize large sets of text. In this instance, case law, for example, and identifying or distilling key concepts that are relevant or related to the issues in your matter. Some of these examples that are shown here demonstrate the GenAI component of a legal research application, the UI, the narrative, plain-spoken response addressing one's prompt or inquiry. The key or a key is not only a written response of the answer, but also the citations that underpin the response. Those are critical and typical of GenAI tools in the e-discovery context. It allows you to take a deeper dive into the underlying support beyond the response, if desired, as well as to validate the response or at least the citation. Now let's get into TAR and GenAI more specifically. The current generation of AI as found in e-discovery utilizes different types of machine learning. The focus here is on supervised machine learning, where algorithms learn from and discern patterns and data with human input in the form of labels, say responsive and non-responsive. You're familiar with predictive AI. Using it matters to provide a value on the likelihood a document falls into or under a certain classification or label, say responsive or privileged, based on previously coded training on documents or review of documents by SMEs. GenAI, part of this next generation of AI tools in e-discovery, creates novel content based directly on the underlying or input data. It doesn't require training by the SMEs. Against the input data, it allows the end user, through prompts, to solicit or develop summaries and to answer or address specific questions or of document sets or issues, whether for fact development, due diligence, or internal investigations. There's a fundamental distinction in the use and application of TAR and GenAI. Now, here, of course, in the top group are fairly standard applications of TAR and AI, whether TAR 1.0 or 2.0 CAL. For the purpose of efficiently identifying document sets, particularly at scale, these are well-established, accepted workflows, methodologies for isolating document sets for a number of reasons, including, of course, the initial identification of an R set or finding similar content in a set, for example. The bottom group, we've touched on the definitions, and we'll get into use cases in a moment, but first, focusing on TAR and CAL just a bit more, here are some common use cases. ECA, data minimization, information retrieval, QC, correlating review workflow streams to different review team levels or groups, onshore, offshore, 1L, 2L, and so forth. Myriad applications. And often, if investing in established workflows, efficient, repeatable default workflows that become as routine a part of an e-discovery matter or program as any other integrated component. More challenging use cases, but less challenging, I would say, than they were even just a few years ago, are some of those that are shared on the right hand of the slide. So staying with TAR and CAL for a moment, why do we use them? Recommend them, find success with them? Because they increase efficiency and quality dramatically, of course. Here's a simple visual representation of that. Almost a chronological progression of review philosophies, or at least opportunities, increasing in acceptance and efficiency, leveraging the work product of the SME via technology. Because machine learning algorithms can analyze document content far faster than human reviewers, of course, TAR allows predictions to be made extremely rapidly over large document populations. That in turn can be used to locate responsive material much more quickly and even reduce the total number of documents that are being reviewed. Now, let's look at GenAI and deep learning use cases and applications in e-discovery. Several are listed here. Let me dig into one example: document or issue synthesis or summarization, the third bullet there. Say Privlog development, particularly narratives or descriptions generated by GenAI. I've had many clients who've enjoyed really positive outcomes in terms of quality and speed in using GenAI to generate first draft Privlog descriptions. Does it eliminate contract attorney or outside counsel review work on or towards the development of a Privlog? No, it doesn't eliminate it, but it does, like any good application of technology, change the workflow, amplify the work product output of the SME, and increase productivity. It increases speed and quality at a bare minimum at 1L in this context in a material way. And of course, the greater the scale, the more pronounced the impact. Perhaps the most interesting thing I experienced in running a GenAI tool for this purpose is that in generating poorly constructed priv descriptions, the GenAI tool identified privileged documents, Privlog documents that weren't really privileged. Whether marked privilege as a byproduct of human review directly or as a byproduct of a model indirectly or some combination of the two, closer look at those documents and examining that weak priv description revealed that the document oftentimes was not in fact privileged. So the GenAI tool provided a bit of unintended, unexpected QC. How would poor priv descriptions manifest or present themselves? Most often in one of two ways. Either there would be no legal hook, even though that had been written into the instructions of the GenAI prompt, so no requesting or containing legal advice or its equivalent was apparent in the description. The second was that the description was just too long. What you often ended up with was something that was burdensome or confusing, meandering, or even worse, something that revealed legal advice amidst the lengthy text, or other business proprietary information that client or outside counsel wouldn't want to disclose. Some of the challenges I think that remain in that particular area, joint defense and common interest, those are much less common, but they are a bit more difficult, I would say, to suss. Work product is more typical, of course, but it's a little problematic, at least with respect to identifying the underlying litigation and integrating that accurately and consistently into the narrative, into the description. In any event, that's just one sort of very specific application, one specific example of how clients are using GenAI and e-discovery to substantially assist their work and in controlling cost and quality. To continue this discussion, I'm going to turn it back over to Chan.
All right, thank you so much, Matt. And yeah, I'm going to continue talking a little bit more about specifically in the litigation context, really why generative AI is here to stay. I'll just jump right in. And so this is a standard litigation flow. We have identified key areas where generative AI has currently seen a real-world application. There's likely going to be a lot more as the technology matures and new use cases develop. And we're going to dive a little bit deeper into each stage and see and explain how generative AI can specifically help. And one thing I'm going to call out before I jump in is there's going to be some themes that you'll notice that generative AI is pretty good at doing, and they can be bucketed into the following categories. And those are fact-finding, prioritizing and organizing information into digestible formats, and synthesizing work product grounded in facts from those documents. And so really just jumping right in, typically you have a complaint that's filed. There's a motion to dismiss. Assuming the complaint survives the motion, the case goes into an early case assessment stage. And this is where generative AI tools like Fileread can seem to provide a lot of value in the beginning. Really where you can, with your initial set of documents, you can compare the facts in the complaint with data from documents. You can start to determine those key storylines, do your initial document summaries, identify the initial hot docs without necessarily building out a review team, identify custodians to include or exclude, find gaps in data to negotiate around, and then really assess the strength of the case for settlement. Because if you're representing a client and you find that there's some pretty egregiously bad information in your documents, it would probably be a better idea to settle rather than to litigate. But assuming the case actually turns into a litigation, you're going to have your meet and confers through negotiations and discovery orders. There's a separate stage of the RFP process that's not included here. But while that process is happening in parallel, your client or you might get hit with interrogatories, and in order to respond to them, you can do things like find those facts to respond to those more quickly than more precisely than search and review. You can load these responses into a tool like Relativity for a quick recall. And then assuming now both sides have produced documents, now you have the inbound discovery. This seems to be the stage where much of folks that use generative AI for e-discovery have seen a lot of value. Really, the goal here is like everything is technically responsive, but not necessarily relevant to what you're looking for. So the goal here is generative AI can help you find those new hot documents fast. You can generate those chronologies and other story-based work products with a full data set. You can identify deficiencies to support motions to compel. And as we did earlier, but now you can recompare the allegations and complaint with data from both sides. And then also get answers to discrete questions that rely on other parties' data, including for settlement. And so the last point is something that we hear very commonly where you may have a review protocol, you might be following a certain process for the document review stage, but inevitably something comes up that wasn't accounted for that requires your team to take an additional deeper dive, which can increase your risk of increased discovery time as well as budget. And then deposition prep. So really, there's a lot of work that looks like document review outside of the traditional first level and second level review. And generative AI is a natural fit here as long as the responses are grounded in the documents. And so depo prep is one of the stages, especially when you're starting to generate those key work products like chronologies, timelines, understanding the cast of characters and bios, understanding organizational and relational charts. And when you're building your depot outlines and binders, really the tool like a generative AI tool can really help you find and organize these facts for creating these outlines and potentially automatically match up those key documents to those key points that are in your deposition outlines. And then once you've done depositions, now you're in case analysis, discovery is now closed. During this stage, you want to really assess how strong your story is and supporting evidence at the close of discovery. Generative AI tools can help you generate high-quality outputs for client briefings, and then also identify contradictions between depot testimonies and or documents. And so this especially is an expensive endeavor to do manually. It may take an associate a few days to weeks, depending on the deposition length and documents, with no guarantee of actually finding anything useful. Generative AI can help you quickly locate and synthesize these document-based information that support opposing propositions that your team can actually then verify. Motion for summary judgment really help you identify and organize key discovery content to construct these fact sections that tell strong stories through using hot documents to depot testimony. And then here's also what you would call out the presence or absence of data supporting a given claim. And there's an additional one that wasn't included here, Rule 56.1. When you're building out your statement of facts, a generative AI tool can really help you organize and find those documents that really support the propositions that you're making in there. And assuming your case actually does go to trial, this is another tool to help you stay quick on your feet. So once again, like before, it can help you identify contradictions to impeach witnesses. You can get discrete answers from data on the fly, keeping you quick on your feet. And then also generate work products similar to those for depots like chronologies, cast characters, summaries, and memos of key disputed facts. Jumping right in. So this is typically how an example of what a chronology would look like using a generative AI tool like Fileread. This was run on our McKinsey/Purdue opioid database. So generally, you have the response was returned in the first 30 seconds, and then it took about 5 minutes to generate these citations. And this response actually referenced around 100 documents that were in the data set. And typically, if you were to have like a paralegal and associate do this manually, it would typically take you 3 to 5 hours. And so this type of response really follows the theme of synthesizing information that's grounded in the facts. The green letters that you probably can see refer to the specific areas in the documents that are relevant to their adjacent statements. And similarly, a fact memo on McKinsey's marketing strategies. The performance metrics are pretty similar, 30 seconds for the response, 5 minutes for citations. To do this manually, it would take an attorney 2 to 4 hours. And similarly here, this type of request can generate a more comprehensive response to a particular topic. So imagine you learn something from a witness that you want to verify. A tool like this can help you provide you with the key points that may support or contradict the propositions. And then I talked a little bit about like grounded in the facts. What does that actually mean? And so what I mean by that is you want to look into tools that give you a way to verify and validate the answers that come back. And so a tool like Fileread has pinpoint citations to the documents, the source of truth, so that whatever answer comes back can be validated so that you can trust but verify the answers themselves. And so this is something that I heard across multiple customers. And so this is pretty interesting. Like folks who really trusted like TAR and other techniques that were mentioned earlier, they're a lot more excited about them now. And with a new paradigm like ChatGPT or generative AI, it seems to have given them the impression that the older techniques are more proven and more robust. Yes, there's more data to support that, but those techniques have already like been pretty robust for almost a decade now. And so really this type of just trust in generative AI has actually increased in interest and demand for these traditional AI and ML methods in litigation. So predictive coding, CAL, TAR, et cetera, these techniques aren't going away anytime soon. And we really encourage that you also use this as part of your litigation flow. This is a snapshot of the types of companies that are on the market currently. In litigation, we're going to focus a little bit more on like the discovery stage. There's companies like the big providers, the e-discovery providers like Relativity, Reveal, and Fileread, like I mentioned, is a tool that integrates directly in there. There's obviously other horizontal platforms like legal research, like Casetext, Wexler AI, and not going to mention Thomson Reuters because those are large companies, but these are some of the upstarts or startups that are in this space and starting to provide interesting solutions to these problems that have been in the market. And so one of the biggest fears, it seems, and the distrust with generative AI, and logically so, has to do with hallucinations. But what we want to kind of really educate people on is that hallucinations aren't actually bugs; they're features. The reason why these are the case is because it has to do with the way that these generative AI models are trained. They're trained to predict the next word, not necessarily based on the knowledge. And so when it seems to say something that's plausible, but not necessarily truthful, it's because it's trying to make sense of the grammatical and the and produce a statement that is coherent in the English language, not necessarily true based on the truth. There are techniques that we're going to go into a little bit that guide the model into staying truthful to the actual source. But for the most part, these generative AI tools are going to, by their nature, are designed to essentially hallucinate, or in other words, be creative. And so really, AI hallucinations occur primarily due to two reasons. One is either their misinterpretation or invention of facts. So these legal AI models may present false information because they cannot perfectly distinguish between verified sources and irrelevant or misleading data, which means this can lead to responses that seem accurate but are based on incorrect facts or non-existent case law. Or two, misgrounded citations. So some AI models can actually cite legitimate sources or statutes, but misapply them, suggesting they support a point that they do not. So this can be very problematic in legal research where precision and relevance are extremely important. And so misleading citations can result in users making incorrect legal arguments or forming misguided judgments. And so why do these hallucinations persist even with these advanced methods like retrieval augmented generation, which is a technique which aims to link the language models with structured databases? So RAG is a technique that can help reduce errors by anchoring response to factual database. It's not a foolproof solution. And the reason why, especially in legal research, it's problematic is that the complexity of legal information, the nuances of jurisdictional differences, and the ever-evolving nature of law make it difficult for these models to fully capture and apply the accurate legal knowledge. And to really tackle these challenges, we need greater transparency, benchmarking, and user caution. Legal professionals that are using these AI tools need to be vigilant, always cross-referencing those responses with reliable sources, especially when it comes to high-stakes scenarios. And additionally, there's ongoing improvements in AI training, incorporating clear legal standards, and defining hallucination parameters could make AI tools like this a more reliable tool in the legal practice. And so this graph here kind of talks a little bit about a study that was done by the Stanford research group, comparing how often these types of models hallucinate or produce incomplete responses. A whopping 16% of all of these tools had instances of hallucinations. And then in this case, these are some of the examples that I caught. So for example, I'm going to start with Westlaw's assisted research product. So this tool actually fabricated a rule within the federal rules of bankruptcy procedure, falsely claiming a jurisdictional rule that does not exist. So it potentially made up a rule. The AI's reference actually contradicted Contract versus Ryan, 2004, a case that actually clarified that certain bankruptcy deadlines are not jurisdictional, and that this type of error is potentially very risky because it can lead users to adopt legally incorrect frameworks. Lexis AI, which is the top right, this one made a significant error in interpreting the constitutional law by citing the undue burden standard from Casey as still applicable, but the standard was overruled by Dobbs versus Jackson, which replaced it with a rational basis review. And this mistake really illustrates their limitation in staying current with the recent landmark decisions and understanding the evolving legal landscape. And on the bottom left, we have the practical law. Practical law actually provided incorrect information regarding Justice Ginsburg's stance on same-sex marriage. Rather than correcting the user's misinterpretation, it actually compounded the error by adding further incorrect statements. So this case actually highlights the tool's failure in managing the user's misunderstandings, as well as expectations, which can lead to misguided legal interpretations. And GPT-4, which is this general purpose language model, this one made a notable error by hallucinating a provision that does not exist. And really this is a highlight in terms of their limitation in recalling precise codified and legal content, and showcases the risk of relying on models without a specialized training or database, because GPT-4 was not using a RAG model, it was just done wrong. And so talking about these risks, we can bucket these into 4 different types of AI risk. And so they are misuse, which are unethical or illegal exploitation, essentially things like deepfakes, spam, and fraud. A notable example here could be that it's really super easy now to clone somebody's voice. And there are a lot of new scams going around where people are impersonating loved one voices to extort family members. Misapply, really plausibility over accuracy that leads to inaccurate outputs. So for example, an AI model generates case law containing fabricated information due to misinterpretation of data. This is a classic problem that has occurred in legal research in an infamous set of news. Misrepresent. Third-party generative AI content is disseminated despite questions about its credibility. So an example of this would be like competitors intentionally using AI-generated misinformation to mislead the market or manipulate the public perception, adversely affecting the organization's market position. Misadventure, accidental consumption and sharing of fake content by unaware stakeholders. An example of this could be employees unknowingly rely on AI-generated reports that contain inaccuracies that can lead to flawed business decisions. Well, we hope we didn't scare you away with the issues that we discussed today, but with any new technology, there's always limitations and pitfalls that we're learning about and also finding workarounds and solutions for. But there's just as much risk with non-adoption, if not more. And so we're going to dive a little bit deeper into some of the reasons why and provide a guideline on how you should be thinking about them when it comes to solving your problems. So did you guys know that data doubles every 3 years? And so per the IDC Global Data Sphere forecast, that there's a compound annual growth rate of 23% from 2021 to 2025. And so per the EDRM, the ED Scholar market will experience a 8.5 compound growth rate. And according to Fileread, 90% of the world's data was created in the last 2 years. And every 2 years, the volume of the data across the world doubles. Oh, every 3 years, the volume of data across the world doubles in size. And so currently, estimates suggest around 0.4 zettabytes of new data is created each day. What is a zettabyte, you ask? It's about 1 billion terabytes. And so according to Deloitte, it's actually projected that by 2025, our global data volume will reach 175 zettabytes. So this is a curve that you can that illustrates how big the data is growing. This is from a different source, from Statista, but it's in line with the Deloitte's report. Versus we're seeing a 5% growth in legal employment. We saw a 5% growth in legal employment in 2023. And so we're not necessarily reading or comprehending information much any faster year over year. The growth of data is far outpacing the growth of the SMEs entering the market. But the lever we can pull is technology. We can control the technology that we use to stay on track with the demand that we're seeing. And so, as you can see, only adding headcount isn't a viable solution anymore. There is the risk of quality control and the lack of consistency by hiring new reviewers. There's also the risk of increased overhead incurred in just managing these teams, especially as you're scaling up. So how do we keep up with the growing data demands? So we're going to talk a little bit about how you should be thinking about your options. If you feel that now you're starting to feel the pain of like, oh, there's too many documents, there's no possible way that you can get good coverage on those. There's a framework that we think that will make a lot of sense, especially if you're excited about generative AI and applying it into your practice. So really, the biggest question to ask yourself is, if you're interested in generative AI, you should ask yourself, does it even actually solve your problem? And so in terms of functionality and performance, does the AI tool actually address your needs effectively and efficiently? Customization and flexibility. Can it actually be customized to fit your needs? And is it flexible enough to support a variety of use cases that may come up as you use the tool? Vendor evaluation. We're going to go a little bit into a bit later, but you want to always want to check if the vendor is trustworthy and knowledgeable and supportive of anything that you're trying to do with your goals. Integration and compatibility. Does it integrate well with existing workflows? For example, like a discovery platform, your DMS, maybe Microsoft Word or Outlook, or does it require a separate work stream? User experience and adoption. So even if the tool is great and could potentially provide a lot of value, it won't be helpful to users unless it actually becomes adopted. So one of the things to consider is also how easy is this to use, and will your employees actually rely on it? Ethical and considerations as well. I'm not going to go into too much detail. I think there's an entire CLE based on this one. But really, you want to understand where the data goes and any inherent biases with the system based on the internal models that it's using. Data management and security. Really, you want to ensure that the tool falls under the right compliance and data protection requirements of your firm, your corporation, or even your country. And obviously cost and ROI. So even if a tool seems like it costs a lot, it still might be worth the value it provides. It might still be worth purchasing if the value actually drastically outweighs the costs of implementation. And so when you're thinking about adopting this technology, you want to also think about what is it actually doing? How is it going to sit with your existing in software engineering, there's a concept of tech stack, which are the software tools that you use on a daily basis. And so is it a pure replacement of an existing tool? So for example, we moved from Skype, WebEx to Microsoft Teams. Is it more evolutionary? So is it going to sit alongside and enhance existing software? So we used to have for example, if you had like on-prem solutions, now we're using the same type of software on a cloud service. Similarly, tools like add-ons to Relativity, that can also be a type of evolutionary tool. Or is it revolutionary? Is this new technology being introduced almost in isolation to enhance a new service line or business function? So for example, let's say you want to build out a customer service chat for a new business function that you've introduced. And now with these LLMs, it can actually do a lot of that work for you. And obviously, security is a big, big issue here. So many firms and corporations actually just straight up banned the use of ChatGPT and other large language model chatbots. And the reason why is because these tools can use your inputs to improve their performance, meaning whatever sensitive data you include or enter can potentially be viewed by others. And the secure way to use these tools is to work with an enterprise environment or deploy an open source model on your own environment where you have strict controls on the data flow and networking, which can also allow you to compartmentalize the information that you actually interact with, that the tool interacts with. And then if you're working with vendors, definitely some certifications that you should be looking for. These imply but do not guarantee security. So things like ISO 27001, ISO 42001, which is a new standard that came out this year for artificial intelligence, SOC 2 Type 2, HIPAA, GDPR. But there's definitely a few more, but these are the main ones that people seem to trust and rely on when interacting, when assessing for security. So assuming you've now met that criteria of, okay, I feel that generative AI is for me. Now you want to get into the stage of how do I actually evaluate the tools? Because maybe you don't want to just use your live data as part of your testing, as part of testing. And so one of the ways that a lot of folks have been demoing these types of tools is using the Enron data set. But the problem with that is the Enron data set is actually very old. And the implications are that most large language models today will likely have seen and trained on that data, which means any results that you probably see within the Enron scope likely isn't a real world representation of how well it's going to do on your actual day-to-day. And a suggestion that we have regarding that is really consider working with vendors that have adopted unique ways to test AI tools on fresher data sets. They can be using synthetic data or publicly available data sets that are new that these large language models likely haven't seen. And looking forward, I think we talked a little bit about the capabilities of large generative AI today. We want to look a bit forward and see what's even possible in the near future. So multimodal search is an interesting area that's starting to see a lot of traction, especially in the AI industry. So this is just going beyond the ability to extract information from text. So text-based AI models today currently have trouble analyzing these types of information. So things like images, video, audio, etc. These are all incompatible data types that it cannot necessarily understand. And an example here, it's like you may get a lot of these types of slideshows as part of your ESI, where you can do OCR on it, but searching against it is a nightmare. But multimodal is a tool, multimodal function. These types of new models that have come out have now given us the ability to analyze these types of graphs so that you can actually ask questions, use keyword searches against it. And so with these tools, your existing tools become more powerful and useful. So for example, imagine being able to use text to search across almost any type of data. So things like, do any of these images contain fire damage? Or what was the defendant wearing in the security footage? Sorry. And agents, I think this is also almost a buzzword. I think, and rightly so, I think there's been a lot of excitement since 2023 about AI agents, which are defined as computer systems that are capable of executing operations and responding to their surroundings autonomously without ongoing human guidance. So really the humans will set the goals of here's what I want, this is a business objective that I want you to do. And then the AI agents, the computer systems will independently pick the best actions in order to accomplish those specific goals. An example here, it's like AI agents for insurance. You can decompose what it takes to complete an insurance claim. You got to collect data. You got to do risk assessment. You got to automate the claims processing, potentially detect if there's any indication of fraud, and then also provide personalized recommendations for the particular person making the insurance claim. And also prompting is a skill of the future. I think this can sound like a hot take, but I believe this very deeply, where knowing what questions to ask and how to ask them is a core skill of attorneys as it is today. And with generative AI, that same skill is actually extremely important in the context of prompting, which is really the process of providing initial input or instructions to a language model or AI systems in order to guide its behavior. And so sometimes you may get responses that aren't quite what you're looking for, but with a little bit of guidance and tuning, you can actually guide the model into giving you the response that you actually want. And Matt, I think you may have something to add more to this before we jump.
Yeah, sure. I would just say it was interesting when Chan and I first started talking about this presentation and walking through sort of the what we were going to cover and at what level and what depth. One of the interesting things is that independently, when we were getting to sort of like what are our takeaways, what do we most want to, what would we prioritize to anybody who's thinking about these issues for themselves to sort of put themselves in a position of strength to really start moving forward in this area. We independently both arrived at this as our singular or at least number one recommendation. And it might not be a hot take, but I can't stress it enough. I think for anybody, whether it's who's whether in a law firm or a corporate environment, I think this is really something that's invaluable to take some time understanding, caveating this recommendation with Chan's remarks about security and understanding, what your law firm or corporate policies are on this. Otherwise, maybe it's just at home on your home personal computer, but nevertheless, spend some time tinkering with GenAI. Set up your own ChatGPT, for example, and play with the prompts. There's a lot of different things that you can do. Explore whether it's formatting, how to format results, bullets, paragraphs, short sentences, whether it's sort of working with and exploring what the results are going to be, sort of the length, the tone, the level of expertise or depth of substance in the response. All of that, I think, is going to help you get comfortable with the underlying terminology. It's going to help you get comfortable with I think just the process, going through that creative process yourself, I think is going to be really helpful, and also the behavior of the technology. We could spend a lot more time talking about hallucinations and so forth. They can be nonsensical. Sometimes they can even be humorous. But of course, when, oftentimes they're not, and that therein lies a real concern. So again, that roots back in my mind to the citations. Both Chan and I mentioned that. Really sort of I think how important that can be, but just being mindful of that's sort of the behavior. That's why those hallucinations are happening. It's how they might manifest. Here's how you can sort of guard against that, both on the way in with the prompt, structure, but also in terms of evaluating the results. So, I think this is going to be tightly integrated part of our lives, both personally and professionally. This work, it already is in many respects. So I think it's always something that's helpful to equip yourself to be able to speak to it, understand it, and use it, as opposed to maybe getting used by or pushed around by it. And I also don't want people to lose sight of it. Also can be fun. In the process, you can write poetry, draft short stories. Again, all the while, I've done a lot in terms of image creation for my kids, in terms of coloring sets. Um, so there are a lot of different ways. Nevertheless, you're still, that sort of self-study, that developing and understanding appreciation of these tools and sort of the progression of the technology, I think is always only going to advantage you, in the work that you're doing, help you understand how the tools work, and help you work with your e-discovery partners or clients more effectively and efficiently. Now,
Right.
Katie, sorry. So, Chan, I don't. If you had some more comments on that, or
No,
just any
I
of
think
the
that's
other
it.
issues. Katie, I don't see any questions in the question and answer um, section. I want to make sure that we're not overlooking uh, any questions from the audience.
No, I don't see any questions coming in.
Okay, that's great. Um, yeah, I'm just trying to think in the 2 minutes or that we have left. If there's anything specifically, I think we really just covered um, a lot of it. I do think it's worthwhile to understand, uh, at least familiarize yourself with some of the different sort of like more established applications, whether it's legal research, contracts. I think a lot of people probably have, but also then that's given you, I think, a really good understanding of LLMs and deep learning. But then as you move into Gen AI, into more extracting from document sets, really playing with those document sets, how you can be drawing out summaries, key issues, synthesizing, the document content for very specific fact development issues, chronology, and so forth. I think it's really an incredibly powerful and invaluable tool to very quickly, very efficiently, at not a great deal of cost, to access, to sort of shortcut, at least at a draft level, um, a lot of that work otherwise that a lot of us often find ourselves doing.
Absolutely.
So one last check to Q&A. I don't see anything. Can you see anything in the chat, Chan?
Uh,
Is there anything there?
I, I believe they don't have access to this
Oh,
Zoom.
okay.
So, no, I don't see anything.
Okay. Well, I would just, I guess the last thing I would say is just to reemphasize the risks of non-adoption. We've gone over, I think, what the capabilities are, some of the things to be concerned about in terms of security, tips about training, getting yourself more familiar with it and so forth. I think, some of the risks of non-adoption is just really the explosion of data, and being able, everybody is painfully, I think on this, in this session, painfully familiar, aware of that phenomenon. But it's certainly not going to slow down, I wouldn't think. If anything, it's really sort of accelerating. So putting yourself through the technology, but also the people that you're hiring or developing, ensuring that you're empowering them with the skill set, to make use of this technology. So, you're doing so as efficiently as possible. Otherwise, I think that's it. We certainly
And that's it.
appreciate everyone's time today. We hope you have found this informative, instructive, and helpful. And we are more than happy to stay on, answer questions, or follow up with either or both of us after this presentation to address any issues or questions you might have.
Oh, you know what, guys? We did have one question come in.
Okay.
It says, where do you think AI will be in 10 years?
That's a really
That
interesting. Go ahead, Chan.
that is definitely an interesting question. I think we've seen tremendous acceleration almost in this space over the last 2 years alone. Um, yeah, I would say in the next 10 years, we'll definitely have some form of like general intelligence. Will it be like the singularity that everyone fears? I'm not sure, but I think for a lot of the more less complicated tasks, I think we will hopefully not worry about having to do those ever again. And I think the next 10 years, hopefully we'll have robot servants taking care of all of our needs so that we can focus more on the things that really make us human.
Yeah, I don't know. I mean, in the e-discovery context specifically, I think we are often, we're sort of locked in this never-ending battle between developing ESI formats and the tools that are capable of efficiently synthesizing those. So I think what we're going to continue to see is an integration of that AI capability uh, through sort of that vertical stack, almost, if you will, machine learning through, GenAI integrated into our e-discovery uh, uh, platforms to help us use that specific part of technology as the most powerful, instrument in the toolkit to meet our e-discovery obligations. So I think you're going to continue to see that progression, and I think by 10 years, yeah, Gen AI is going to be as second nature as to us as many things simple technology is to us today. But great question.
There are no
All
other
right.
questions, just some thank you comments, and they say happy Wednesday.
Happy Wednesday.
Thank you very much. Likewise,
Thanks, everybody.
appreciate everybody's time today. Thank you very much.